Now we're gonna go and head over the usage of useMemo. It's a native React hook for memoizing functions and objects which you can put dependencies on, and whenever the dependency that you put on the useMemo function changes, it will return the function. It will execute the function of whatever you memoize, and at the same time it's going to return the value. What we have here is a simple application on which, if I click the switch light button, the paragraph element here will turn to white, and if we switch light again, it will turn to dark, which is simulating a switch bulb. Nothing fancy there. On the second paragraph, we have here a value or a number counter on which, if I click the increase number, it's going to increase the initial state from 0. It's going to add 1, and we're going to utilize a function called let's call it slow function. But what it actually does is that it returns the number of the current state, and that it doubles it or multiplies it to 2. We'll be talking about this one, the for loop here, which was initialized to run over a billion times, if I'm not mistaken, is just a way to simulate on how we can effectively use the useMemo hook. So if you notice, if I click increase number again, it's gonna add 2 plus 1, and then it's gonna multiply it, which will result into 4. But you can see the transition of how this executes. It's quite slow, so it takes more than I believe 5 to 10 milliseconds in computing time before it actually succeeds and operates the function, and that is due because of this. So as you can see, the application is slow, and this particular line here on which I set the number and the current number value is actually separate from the ones on the above, which is the switch light status. So what we're gonna do here, or as what you can notice, this is not dependent on this function, but if I switch the state of my application, because the switch light here, the reason why this is slow as well is because every time your application changes its state, the doubler function here on which I set the slow function will try to recreate itself every time it renders. Hence, it affects the part of our application on which we try to switch the light status. So what can we do to improve this further? Well, this is where useMemo comes into play. So what we can do here is that we can wrap this slow function using the useMemo hook. So we use useMemo. Right. useMemo, and then we're gonna wrap this function here, and as a dependency, what we're gonna do is we're going to set the num value, because this is the one that we're trying to utilize and we're trying to show it here, and we're going to set it here, and just like that. So what this implies, or what simply means, is that whenever the num value changes, I want you to call this slow function. Now if nothing changes on the num value and I try to change the state of my application from a different hook like this one, set lights, then this should not recreate itself, and this should not slow down the the usage of the use state of other hooks. So we're gonna test that right now. Actually, my bad, guys. So the way I set the useMemo hook was quite wrong. So what we should actually do is we use the useMemo hook, and then we declare a function, and then inside that function we are going to return the slow function that we created below right here. And remember, whenever we call this function, what's gonna happen is that useMemo is going to return the function, and it's going to execute it and return the value of which this slow function actually returns as well. So what we're gonna do here on the markup is, instead of actually initiating or executing the doubler function, what we do now is just put the doubler here, and automatically what it's gonna do is that it's gonna call useMemo and then execute the function that return the value. So if we check the output of our app now, so if we refresh this and say increase number, it's still slow because we're still trying to simulate simulate this, because we have the for loop here. But now if we head over to a different hook, which is this switch light, so a while ago this was slow, but if you can test it like right now, it's snappier compared to how it previously performed. And the reason is because whenever I'm changing the state of the switch light, the doubler function here, which returns the useMemo hook, is reading that, hey, the current number, which is 2, did not change, and we did not initiate a call here in the increase number button. So what's gonna happen is that, okay, forget about it. What useMemo is gonna do is, okay, forget about it, we're not gonna run this because the dependency or the number did not change at all. So in any other circumstance that this change, then this will rerun. But since we are initiating a React state change on a different hook, like this switch light, then it's not going to, re-render. It's gonna stay the same. So that's good. However, if we talk about referential integrity, now referential integrity or referential equality, if you know the basics of React, it simply refers to how two different objects differ from each other. So say for example we have something like this. We have a sample object here, we're just gonna call it wall team, right? Wall team, since we're like trying to build a house application. So what we have in the wall team is an object which contains the following properties. Let's say the color would be it's gonna be dependent on the light. So if the light is true, then the color would be just plain white, or if it's not, then it's gonna be plain dark. Or 1 2 3, right? 1 2 3 hex code. So there you go. Now this is an object, and it is, whenever this is initiated, it refers or it is placed in a special memory on the application with its own memory space. So if we create something like this, so if I duplicate this and call this wall team 2, you might think that, okay, they are the same because they have the same property. Well, you're wrong, because the way how these things work in JavaScript is that whenever you create a new object, it's going to refer to another memory space allocation in your application, and they are entirely different. So let's say we have this use effect hook, right? So another application of the useMemo is on scenarios like this. Say for example we have this, we're gonna use effect hook, and every time, let's say for example the dependency will be the wall team, right? Every time this change, I want you to run this simple logging console log team change, right? spell that right. Theme change. So if we head over to application, if we try to hit refresh, it's gonna say theme change. Okay, nice, no problem. And it depends on the wall theme, right? But what if we say, for example, if I try to like push the increased number switch or state again. So if we try to click this, you're gonna actually see here that the theme change inside our use effect is re-rendered. Why? Well, that's because we need every time, see here, every time we try to change the state of our application, it re-renders everything here, or it recreates everything here, including this small object. So what we can do here is say useMemo, and don't forget that it returns a function. Then inside that function, we're going to return the object, which is the color lights. So here we can just simply say return this. This is what I need. So we're going to return that here. And say, for example, where did I go wrong? Maybe this one. useMemo. Sorry, quite worse doing TypeScript. But yeah, useMemo, and then the only dependency that we're gonna put here is the lights, because that's the only object that it's akin to, or it's depending on. So if we try to do that again using the useMemo hook, we should be able to, let's try to refresh this first. If we try to switch lights, it's gonna change its theme because it's depending on the lights object here, and that's we are dependent on the wall theme there, wall theme object as well. But if I try to click the increased number again, we should not be able to see a re-render for the use effect. So if we try to click this, as you can see, it proceeded with and executed the useDate function, and as you can see, there's no more additional re-render for the theme change. So these two are the most practical way on which you can utilize the useMemo hook. Now, you might be wondering, okay, it might be better, especially if you're building a very large application, it might be better to use this like all the time. Well, that kind of depends, because though this gives you like performance boost for caching your function, you have to also remember that it consumes more memory in your application, and the you should only put this on parts of your component wherein the process takes too long. In our instance, we just initiated like this one, a long for loop, just to simulate how slow this could take. Maybe on your application you could put that, under that pretext or under that context, and you can see some performance boost. But on simple stuff, whether you're just like changing views or switching to another component without actually performing async calls or GraphQL calls or API requests, it might be better to perform or write those things like natively without having to make use of this. But the key takeaway from this is you have to be very careful on where you're going to utilize this hook, because though it might give you performance boost, but at the same time it might give you overhead memories for your application. So that's how useMemo, the useMemo hook works. In the next one, we're going to explore how the use callback differs from this.